Hello student, in this video we will study about the image formation in convex mirror. In the last two videos we studied about the plane mirror and concave mirror. In this video we will study about the convex mirror and we also study about the formulas that is used to solve the problems in reflection of light. If you watch part 1 and part 2, so it will be better for you to understand this part 3. So now we can start the video. So here in convex mirror, we have two positions of the object. Object can be placed only at two positions. So why the object is placed only at two positions? Because see, if we have a convex mirror, here is the focus, center of curvature and the pole. So in the light side, object can't place. Because it's a non-reflecting surface. So object can only place on the left side. So based on that, there could be two positions of the object. First position is at infinity. And the second position is between infinity and pole. So we can start the image formation when the object is at infinity. So first we draw the convex mirror. Pole, focus, center of curvature. So as we know, when the object is at infinity, it means that incident ray is parallel to the principal axis. So here two incident ray we will take which is parallel to the principal axis. So let's take, this is one of the incident ray. So we also studied in our part 2 where I explained you rules of image formation. In that, when the incident ray is parallel to the principal axis, it always passes through the focus. So this incident ray, when touches the surface, it gets diverged. And then its dotted line will pass through the focus. Similarly, one more incident ray, it is parallel to the principal axis, so it will diverge and this pass through the focus. So both the reflected ray is meeting at focus. So in this case, the nature of image will be, first it is highly diminished. Second, it is virtual and erect. Why it is virtual and erect? Because image and object are in the other sides. Means object is on the left side and image form on the right side. So that's why it is virtual and erect. And third is image is formed at focus. So this is the image formation of a convex mirror when the object is at infinity. Let's move to the second position, where object is between infinity and pole. So quickly draw the convex mirror. So we can place object anywhere between infinity and pole. Suppose we place it here. And two rays will emerge from the head. One we can take parallel to the principal axis. So in the previous example, it will diverge and it will pass through the focus. Second, we can take through the pole. So here reflected ray will be dotted line. So what we noticed, both the reflected ray meeting behind the mirror and the size of image is diminished and it is between P and F. So that is our nature of the image. So nature of image, it is diminished. Second, virtual and erect. Third, image formed. Between pole and focus. So here one thing I try to explain. If I try to compare plane mirror concave mirror and convex mirror. So plane mirror always forms a virtual image. Concave mirror can form real image and virtual image. But convex mirror always forms a virtual image. Okay, I understood. Plane mirror can form virtual image. Concave mirror can form real and virtual image. Convex mirror can form virtual image. So here one more thing we need to know, that plane mirror forms the virtual image and the size of image is equal to the size of object. Means in this case, Hi is equal to Ho. Similarly, in the convex mirror, virtual image is formed, but in this case, size of image is less than size of object. Means in this case we can say that Hi is less than Ho. In concave mirror we have also virtual image, that is between P and F, but in this case size of image is greater than size of object. So it means that here Hi is greater than Ho. This is very important result that I'm noting it down. It will increase your confidence and it is helpful especially for MCQ type of questions. I'm not discussing about a real image because my focus was to explain about the virtual image, but you know that in real image, according to the position of the object, height of image and height of object changes. But in virtual image, plane mirror, concave mirror and convex mirror has different approach with respect to height of image and height of object. I hope you understood this part clearly. Now we will study about the usage of concave and convex mirror. First we see the usage of concave mirror. Concave mirror is used in torches, vehicle headlights, it is also used by dentists, to see large image. Third, it can be used as saving mirror. And fourth, used in solar furnace. So if we talk about torch, so in torch we are using a concave reflecting surface. If you see the torch, you will see that some shiny thing which is in the curved structure is present inside the torch, and there is a bulb that is at the center of that concave mirror. So basically how it works, here is the concave mirror and at the focus, let us assume this is the focus, bulb is present. So when we switch on the torch, bulb will glow, and from that incident ray will start coming out. Many incident rays are there. So we know that when any incident ray that is coming out from the focus, its reflected ray will become parallel to the principal axis. So all the reflected ray will parallel to each other. So due to this, we can see an object that is 4. Now next is usage of convex mirror. It is commonly used as rear view mirror. Here I want to explain you one question. Why we use convex mirror as a rear view mirror. So what happened? Plane mirror always forms same size of object. Second, viewing angle is less in the plane mirror. I will explain this part also. But in the convex mirror, we get the diminished image and viewing angle is more. It means that if we have a plane mirror, we can only see the object that present in this range. But if we use a convex mirror, our viewing angle increases. Now you see our range increased. So what happened? We can see more number of vehicle, but the size of that vehicle will be diminished. But in the plane mirror, we will see the less amount of vehicle, but that vehicle will be seen in a bigger size. That's why for better visibility, we use a rear view mirror. I hope you understood this part properly. Second use of convex mirror is we can used as parking mirror. So these are the uses. One more we can say, it can also use as security mirror. Now let's move to the next topic. So here, linear magnification. What is linear magnification? Linear means one dimensional. And magnification means how much image is magnified. So, what is the definition of linear magnification? It is defined as the ratio of height of image to the height of object. So here, if we represent hi as the height of image and ho as height of object. So linear magnification which is represented as a small m is equal to height of image to the height of object. So this is hi and this is ho. So m is equal to hi by ho. This is the formula that we need to remember. Linear magnification has one more relation equal to negative of distance of image from pole to the distance of object from pole. So here small u is represented as distance of object from pole and a small v is represented as distance of image from pole. So here m is equal to minus v by u. If you combine hi by ho relation with minus v by u, so we can say that m is equal to hi by ho, that is equal to minus v by u. So this is a complete relation of linear magnification with height of object and image and position of object and image from pole. Now next topic is sign convention. Sign convention is very important for numerical point of view. If you are able to understand this concept, then you can easily solve the numericals based on it. So let's move ahead to our next topic. In sign convention, we need to remember certain rules. So this is a figure of concave mirror and convex mirror. We can name the pole, focus, center of curvature. In part 2, we studied about the focal length, that is the distance between focus and the pole. So this is our focal length. Here is the radius of curvature. That's the distance between center of curvature and the pole. Same way, this is the focal length and this is the radius of curvature. So rule says that anything that is present on the right side will be considered as positive. Anything that is on the left side will consider as negative. Left and right is divided based on the pole. Pole is the reference. With respect to pole, we divide left and right. Same way in the convex mirror, here is the pole. This side is the right side. So it is considered as positive, and this is the left side. It is considered as negative. Same way, with respect to the principal axis, this is our principal axis. Upward direction is considered as positive, and the downward direction is considered as negative. Same thing for the convex. Upward is positive, downward is negative. I hope you understood this rule of sign convention. After that, I will take few examples to clear this concept properly. Example for concave mirror. Two examples I will take. First example, when the object is between C and F. So we discussed this image formation in part 2. So here what we have to do, simply we have to draw a image formation diagram. Here is the pole, focus, center of curvature, and here is the our object, which is lies between C and F. I can zoom it. Let's take the two rays. One is parallel. Parallel will pass through the focus, and second through the pole. So here, if I put it A and B, that is the height of object, and A dash, B dash, that is the height of image. So AB is represented as HO, that is the height of object. A dash, B dash is height of image. Similarly, PF is focal length, that is represented as a small f. Then AP is the distance of object from the pole, that is a small u. And A dash P, that is the distance of image from the pole, that is represented as a small v. And one more, we can note it down, that is C and P. This is the radius of curvature. which is represented as R. So if we follow our sign convention rule, left is negative, right is positive, up is positive, and down is negative. I just mark the name, height of object, height of image. This is our F, and here is the V, and this is U, and this part is capital R, radius of curvature. So if we try to make a table based on this example, here U is on the left side. This is our U. This is the U. And U present on the left side. So that's why U is considered as negative based on this example. Second, V. V is present on the left side. So definitely it is also considered as a negative. Then F, which is the focal length. F is also present on the left side, so it is considered as negative. Then height of object. Height of object is, as you see, here is the height of object. So it is on the positive direction. So that's why it is considered as positive. Height of image. Height of image. This is on the downward direction. So it is considered as negative. And the R. R is the radius of curvature. That is again on the left side of the pole. So that's why it is considered as negative. Similarly, so here the example that I took, it forms a real image. It forms a real image. So in concave mirror, we know that in 5 positions of the object, real image is formed. So this table that we did it here, it is applied for the concave mirror, which forms real and inverted image. There we can use this table. Next example. In example number 2, we take the object between F and P, means between principal focus and the pole. So here we place the object which is between P and F and take the 2 rays. One is parallel to the principal axis, so it will always pass through the focus. And second, we can take the pole. So we discuss in this part 2 of reflection of light. So there, image is formed behind the mirror. And it was magnified. So here in this case, this is our object AB. This is our image A dash B dash. So here AB is height of object. This is height of image. This distance is our V. That's the distance between image and the pole. And here is our U, the distance between object and the pole. And focal length, this is our focal length F. So if we use this image and try to form the sign convention, so we can make a table. Here U is negative, V is positive. Why it is positive? Because now it becomes the right side and U remains on the left side. Height of object is positive because it is upward direction, and height of image is also positive because it is upward direction. Next, focal length. So focal length is negative because it is on the left side, and R is the radius of curvature, that is also the left side. So in concave mirror, we have two tables. In one table, we use when the image forms the real and inverted, and in the second table, where the image forms virtual and erect. I hope you understood this two conditions of sign convention that we are using in a concave mirror. Now same way we can move to the convex mirror. In convex mirror, we have only two positions of the object and both forms the virtual image. There is no formation of real image in convex mirror. So it means that here only one table is sufficient because we have only virtual image. So let's take an example where the object is present between infinity and pole. Here we place the object parallel. It will diverge and this will pass through the focus. Second, we can take to the pole and its reflected ray will meet like this. So both the rays meeting between P and F. So if this is our AB, this is our A dash, B dash. So AB means height of object. This is height of image. Here this distance is our focal length F, and this is our radius of curvature R. Now AP is our U and A dash P is our V. So if we make our table, here U is the distance between object and the pole is on the left side, so it will be considered as negative. V is the distance between image and the pole, that is on the right side, so it will be considered as positive. F, which is the focal length, that is on the right side, so it is considered as positive. Next, height of object, which is considered as positive. Height of image, again it is positive because both are on the upward direction. Next, radius of curvature, which is on the right side, so it is considered as positive. So for convex mirror, you notice all the signs are positive except U. U is only negative, the rest all are positive. So it's very easy to remember. Previously, I explained you about the linear magnification. So linear magnification formula was Hi by HO. So if we are using a concave mirror and it is real, so what will happen? Then height of object will be positive and height of image will be negative. So based on that, the sign convention for the M will be negative. So it means that when M is equal to negative, it means that it will be a real and inverted image. Similarly, for concave mirror, when it will form virtual and erect, so there height of object is positive and height of image is positive. So what will happen? Then M will become positive by positive, so it will form positive. So M is positive, it will represent virtual and erect image. So this concave mirror, when it is virtual and erect, that time M is negative, that time M is positive. Similarly, if you take a convex mirror, it always virtual and erect, so there M is positive. So here is a one question. Let's think and try to tell the answer. If I have three values given, one is M is +1, M is +2, and M is +1/2. You have to tell that here which image is used. If M is equal to +1, then which image is used? M is equal to +2, which image is used? And when M is equal to +1/2, which image is used? You can pause the video and think about it. So here in first example, when M is equal to plus 1. So we know that M is equal to Hi by Ho. And this plus represents virtual image. So virtual image, it's confirmed because it is plus. And 1 means height of image is equal to height of object. So if you recall previously, I explained you here, height of image is equal to height of object. So then it is a plane mirror. So same logic, we will apply it here. So what type of image it is? It's a plane mirror. Next example, where we say M is equal to plus 2. So plus represents virtual and 2 means height of image is greater than height of object. That's why it is magnified. So it means it is concave mirror. Concave mirror always forms magnified image in virtual case. Third is when M is equal to plus 1 by 2. So again plus represents virtual and here height of image is less than height of object because it is diminished. So it will form a convex mirror. So I hope you understood this, all the 3 examples properly. Now after that, we have to study about the mirror formula. Mirror formula is a relation between U, V and F. It means that it is a relation between U, which is the distance of object from pole, V, distance of image from pole, and F is the focal length. So by formula wise, we can say that 1 by F is equal to 1 by V plus 1 by U. One thing we need to remember that here we have to use the sign convention. It means that the value will remain the same, but the sign will change according to the mirror to mirror. If we are using a concave mirror, we have a different sign convention. If we are using a convex mirror, we have a different sign convention. And according to the change in the sign convention, the answer will change. I hope you understood this part properly. In the next video, we will solve more questions. In the next video, we will solve questions based on reflection of light. So you will get more idea how to use the sign convention and how to use the formulas. That's it in this video. Thank you.